Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today we'll start new chapter in System Analysis and Design 2, which is User Interface Design. The objectives of this chapter are first of all to distinguish between different types of computer users and the design consideration for each type. We briefly describe some important human engineering factors and guidelines that help us in designing good graphical user interfaces. We'll talk about integrating the output and input design into an overall user interface that establishes the dialogue between users and computers. Understand the role of operating system, web browsers, and any other technologies for user interface design. And finally, we'll talk about the appropriate user interface design strategies, and we'll especially talk about a technique called state transition diagram to plan and coordinate a user interface. Well, we all know that graphical user interface is a very important part of an information system. You may have designed a very good database, you may have developed a very good algorithm, you may have a system with very high efficiency, accuracy, and other features. But if the user interface is not good enough, if it is not friendly enough, the users will never like your system, they will never use your system. So as designers, definitely we cannot deny the importance of the back end, the algorithm, the database design, schema, the non-functional requirements, but we also need to emphasize the importance of a very friendly user interface design. Now one might ask, we have already considered input design and output design guidelines. What do we mean by user interface? Well, user interface, input output is also a part of the user interface. But here now what we want to talk about in this chapter is how we organize all inputs and outputs into a smooth system. We have designed all the inputs in a system, but we need a way to invoke these inputs or to be able to enter the data in these input screens. So this way can be provided through a menu. Okay, this way can be provided through buttons, this way can be provided through icons. Okay, we may have, like if we have a web-based system, we may have web links. Okay, or we may have, let's say, voice interface. We talk to a system and then it will allow us to enter inputs, right? So an interface can be designed in many ways which help us to invoke the inputs or to get outputs from the system, right? So although inputs and outputs, they are a part of user interface, but in this chapter, what we want to talk about, what we want to learn is how to organize all the inputs and outputs in a smooth flow in a system and how to provide ways so that the users can use these inputs and outputs, right? So this is the overall flow of the information system. So in a web-based system, we may have links. In a desktop system, we may have menus, we may have buttons, we may have icons, we, we can have voice interface, we can have many different type of interfaces. So an interface acts as a glue, right? It acts as a glue which connects all the inputs and outputs together into a smooth and complete system. So I hope you understand what we are going to learn in this chapter. Although input and output are a part of user interface, but now we want to see how to organize them into a complete system, right? So the first thing in the graphical user interface design is the user. So we all know that there are different types of users, and when we are designing a system, we must understand the target users for whom we are going to design the system. Imagine if you are going to design a system for kids, okay? It will have completely different requirements as compared to if you are going to design a system for an enterprise, right? So for kids, you need to have a very colorful system. It should have sounds, it should have animations, it should have very attractive colors. But if you are making a system for an organization, it needs to be simple, elegant, without all these bells and whistles, right? So based on the user, what are the target users? If we do not understand the users, if we do not know for whom we are making the system, who is going to use the system, and what type of specific requirements they have, then of course we should not expect a good system, right? So the users can be classified as expert users who are good at using the systems, at using the computers. So these are the users who have basic knowledge required to use computers. They know how to open a file, they know how to save a file, they know how to go to a particular folder, how to print, and so on and so forth. So they are called expert users. Novice users are, on the other hand, the users who are not experienced computer users, right? So sometimes we also call them casual users. It means that they are not able to use the computers effectively. So we need to classify the user. We need to understand whether we are going to make a system for expert users or novice users and what are their unique requirements. Well, there are many common problems in the interface design which result in confusion for the users. The users, they are confused, they don't know how to use the system. Sometimes they will panic, they get frustrated, they get bored. Sometimes they may misuse the system, or they may even abandon the system, or we may have any other undesirable consequences if the system has one of these common problems. And you'll be surprised that even the good systems made by the big companies, many times they also suffer from these problems. So although in this course it is not a main topic, but we'll quickly go through some of the basic guidelines and some of the basic errors that we should avoid in designing the information system. The first thing is excessive use of computer jargons or acronyms. We have discussed in input and output design also that we should not use specialized terminologies or any shortcuts in the input, output, or other parts of the interface of the information system. Like error 403, it is a complete turn off for a user when he sees error 403. What does it mean? The users, they do not know. Or a SQL injection error has occurred, right? So do not use computer jargon, do not use any abbreviations or shortcuts. If you have to use any acronyms, we have discussed in input and output design chapters that we must provide a legend if we have to use any shortcuts, any colors, any highlights, anything special, any codes, right? So we must make them clear in a legend if we have to use them. So we should not use them excessively. If we use, they should be commonly known in the user community, or we should provide a legend to make it clear for the computer, for the system users. Non-obvious or less than intuitive design. All of you know the intuitive design. Like nowadays, all smartphones, they have a very intuitive design. It is close to the logical thinking. All the gestures that we use in our mobile phones, they are very intuitive. Even a kid is very comfortable in learning the user interface in the mobile systems, right? Like we use pinch to zoom in and zoom out. We use swipe to move to the next or to previous image or any item, scrolling up, down, and so on and so forth. So if the user interface is not obvious or it is not intuitive, then the users will suffer from certain problems. Inability to distinguish between alternate actions. What do I do next? Many times, I'm sure all of us have gone through this frustration in using even Microsoft Office. Microsoft Office is a very stable, very old product which has gone through several iterations. But honestly speaking, I have to use Google many times if I want to do something in Microsoft Word or Excel or PowerPoint. So many times you do not know how to do this thing in a particular system. Inconsistent problem solving approaches or inconsistent design. So whenever you do anything in a system, it should be done the same way in all parts of the information system. Okay, like if you are showing the instructions, let's say on the top right of the screen, you should use the same area in all the parts of the system. Not like in some pages or screens you are showing them on top right, but in others, let's say you are showing the same instruction in bottom left. It's an inconsistent design. So the design, the problem solving approach, all the parts of the information system, the terminology that you use, the expressions that you use, the verbs and the nouns that you use, everything should be consistent, right? So there are certain basic considerations in the user interface design. We'll quickly go through them. Understand your users and their tasks. As we discussed before, that if you are making a system for youngsters as compared to if you are making another system for old people or professionals, they have completely different requirements. We should consider those in designing the interface. Involve the users in the interface design. So we should involve the users in the interface design process to get their feedback and to know what they like and what they don't like in the system. Test the user system on actual users. So we should always test the system on the real users in the real environment by using the real data to get real performance of the system. And practice iterative design. Mostly it is an iterative process. We make some prototypes, we make some screen mock-ups or the initial design of the system. We get user feedback, we again make improvements, and we keep doing this. So these are some of the basic guidelines that we should take care of in designing the interfaces. Then very briefly, some human engineering guidelines or the psychological aspects. The user should always be aware of what to do next. Tell the user what the system expects right now. We should use proper action verbs and clear nouns to tell the users what the system expects from them. tell the user that the data has been entered or it has not been entered correctly. So the users should always know what is going on in the system, whether the data has been entered or it was not entered. Explain the reason for a delay in processing. So we should use a progress bar in if some process takes long time, we should use a progress bar and keep updating it with some percentage also, so that the users know that how much process is done and how much time it is going to take to complete the process. Tell the user a task was completed or not completed. Format the screen so that instructions and messages always appear in same general display area. As we discussed in the previous slide, you can reserve a part of the screen for the instructions, guidelines, or any messages for the users. Display messages and instructions long enough so that the users can read them. Sometimes it happens that you show some dialogue to the user and it goes away immediately, even the user is not able to read it. So probably you are aware of the two modes of the dialogue. Maybe you have studied in Java or in any other programming language course. We call them modal dialogues, okay, and there are another which are called non-modal dialogues, okay. A modal dialogue is one in which it will not go away until and unless the user has dealt with the dialogue, let's say by clicking an OK button, right? Non-modal dialogue, on the other hand, they remain on the screen and the users, they can also interact with the other system. Like search dialogue, it is mostly designed as a non-modal dialogue. You are searching and in parallel you can also interact with any window below this dialogue, right? But if it is a non-modal dialogue like file open or save, these dialogues, they are designed as non as modal dialogues, so that the user has to deal with them to be able to interact with the system, right? So whenever any instructions or any messages are shown to the user, you may consider using modal dialogues so that the user is able to read all the message and then clicks the OK button to remove this dialogue from the screen. Use display attributes sparingly. We can use highlights, blinking, or animations to get attention of the user. However, if you use them too much, it becomes a distraction for the users. So try to use them as less as possible. Default values should be specified. We have seen in the input design chapter also. Anticipate errors that your users might make. Like we discussed about the input validation in the previous chapter. So we try to make sure that the user is not able to enter incomplete or incorrect input. So in the interface, we can anticipate the errors that the users might make and we should try to avoid them, right? So input validation is one way of achieving this objective. Users should not be allowed to produce without correcting an error. Like many times in the systems, you will have seen that with some fields there is an asterisk mark, and it is with a required field. So if the user has not entered an information in this field, he or she is not allowed to move forward until and unless they have put the information here. They have corrected this error. If the user is going to use something that can damage the system, the keyboard should be locked and an instruction to call the technical support personnel should be displayed, right? So maybe the user is going to do something like deleting some critical information. Maybe he has the rights, but maybe he is going to do it by mistake, or something that can damage the entire system. So in certain cases, we can take extreme measures. Another thing is in the interface design is the dialogue. The interface is like a dialogue between a human and a computer, right? So through interface, we also call it HCI, human computer interaction. So the humans and computers, they interact with each other through this dialogue. Just like human to human, when they talk, when two people talk to each other, it is a dialogue. We follow certain guidelines. We speak the same language. A person speaks the same language as the other understands. We always try to be polite. We try to convey a clear message to the person, and we do not insult the people, right? So there are many guidelines that we follow whenever we have a dialogue with each other. Similarly, in the computer systems also, the the flow of all the screens and the messages in a system, it is like a dialogue. So just like for human to human dialogue, we follow certain guidelines. We need to follow the similar guidelines for human to computer dialogue. Like the tone, we should use simple statements. We should use correct grammar in the statements. Do not be funny or cute, right? The people there do not like this kind of systems. Do not insert the users. For the terminology, do not use computer jargon. We have discussed it before as well. Avoid abbreviations or provide a legend to make them clear for the users. Use simple terms and be consistent in the use of terminology and the instructions and the design of the system. Carefully phrase the instructions, use appropriate action verbs. So these are some of the basic guidelines that help us in avoiding the common mistakes in user interface design. Now coming to the technology part, first we talked about the human engineering guidelines, the human part. The second is the technology part. So the first thing in the interface design is the operating system. Previously we used to have this command line interfaces, but nowadays mostly we have graphical user interfaces. And previously mostly we used to have platform dependent system. So the choice of operating system was it was a critical factor in designing any information system. So you have to understand your users are on which platform, and you will make the system for only one or a couple of platforms, right? But nowadays, mostly we have platform independent systems, right? So we do not have platform independent system. So the choice of platform is not very important. Nowadays, mostly we have platform independent system, what we call as web-based system. So the only thing that matters in these systems is the web browsers. Every operating system has a web browser, and it acts as a middleware, as we have discussed in the previous chapters also. It translates the user interface for the different users, and we have an application server which will serve the applications to the users through the web browser, right? So because of growing importance of platform independent system, the only important thing is the web browser. We need to consider browser compatibility whenever we design the system. The platform is not an issue nowadays in designing the system. Another part of the technology aspect in the interface design is the display screens. So again, we need to understand what kind of screens the users have, or we also call it form factor, right? We also call it form factor. Like desktop is one form factor. We have regular PC monitors. We have laptops, another form factor. We have tablets. We have smartphones, right? So nowadays, these handheld devices, they are becoming more and more popular. So we have discussed in the previous chapter also that we should consider the screen resolution and screen size whenever we are designing the outputs or the interface of the systems. So if the interface is large uh, and the screen is small, then we can use two techniques to fit this large interface on a small screen. Either we can use paging, in which case we display complete screen of characters at a time, and when the user moves to the next page, the entire screen will be replaced. Or we can use scrolling, in which one or a few lines are scrolled down to show another part of the interface. So by using these two techniques, paging and scrolling, we can design the large user interfaces for smaller form factors or smaller display screens. Keyboard and pointers are other part of the technology. Mouse, pens, the digital pen or stylus, or nowadays touch is becoming more popular. Now there are certain graphical user interface styles and considerations. We'll talk about them briefly. The most common graphical user interface style is Windows for the desktop system or frames for the web-based system. What we call as WIMP. I'm sure you have studied this in the HCI course. So WIMP is the most commonly used type of interface nowadays. It stands for Windows, icons, menus, and pointers. Or another full form is Windows, icons, mouse, and pull down menus. Right? WIMP. Right? Or we call them menu driven interfaces. These are the most commonly used type of interfaces. Right? We have different type of menu driven interfaces. We'll talk about them briefly, inshallah. Another type is instruction driven interfaces. So there are interfaces which are based on different forms of language. Like we have language based, we have mnemonic and natural language syntax. We'll talk about them inshallah in the coming slides. And another commonly used GUI style is question answer dialogue. These are special kind of interfaces. They are not used as a complete interface style. Mostly QA dialogues are used as a supporting interface with one of these interface styles. But they are sometimes they are a good choice for like an additional style for the users. This is a sample dialog chart. So the user, let's say, first of all, when the user sees this dialog, from this dialog, if the user selects first option, menu option 1, he'll go to warranty transaction menu. When the user selects second option, it will take him to warranty report menu. The third is warranty inquiry. From here, he can further go to these three menus and so on and so forth. So either we can use sample dialog chart, or another similar technique is state transition diagram. We'll see it shortly. It is also a similar technique which is used to design the flow of all the screens in the information system. State transition diagram, it can be used to define the flow of all the screen. Inshallah, we'll see it shortly at the end of this chapter. Right? So the dialog chart and the state transition diagram, they serve the same purpose and they are very similar techniques. This is an example of a pull down and a cascading menu. So whenever you click any menu, it will pull down another menu, and sometimes we have a cascading menu. Another menu like this menu is cascaded inside this menu. When the user hovers the mouse to chart, then the user sees this on this sheet and as new sheet, right? Cascading menu. And ellipsis, it indicates the dialog box. As we had seen in the input design chapter, these three dots, they are called ellipses, and they, it means that the user needs to do something more to complete this task. It will ask for more information. It will not complete the action here. Then pop-up menus, or we also call them context menu. Okay. Context menu. As the name implies, these menus appear based on the context, what is under the mouse pointer. So whenever we right click, like when I right click here, I see this menu. This menu is a context menu, right? So based on what is under your mouse pointer, we show some most relevant commands or actions suggested for that item. So all these choices, they are there in the menu, or they are there on the icon bar also, but they're just to provide an extra facility to the user. We can use this context menu, right? And a context menu provides shortcuts to the user. For example, let me go back. If I end this slideshow, you see, if I right click here, I see this context menu. If I right click here, I see another menu. If I right click here, I see another menu. So whenever I right click anywhere, it shows me the most relevant commands for the item under my mouse pointer at that time, right? So they are called context menu or pop-up menus. Next is toolbar. So this is the toolbar. Okay, this is the toolbar. So these are the icons which provide shortcuts to some commands inside the menus. Again, they are visual component. They make it easy for the user. For some commonly used commands, the access is made easier for the users. Then here you can see iconic menus. We have a menu, and with the menu we also have icons to make it more visual kind of graphical user interface for the user. Then consumer style interface, the customized interface, like Norton antivirus, they use this interface, which is a custom design interface. It does not follow the common WIMP style or on any other standard style. It is the customized user interface styles. Or here you can see an example of a hybrid of Windows and web interface. So it is a desktop system, but it is designed with the hyperlinks, and it looks like a web-based system to a common user, right? Because the users, they are more comfortable in using the web interface. So a desktop system can also be designed to look like a web-based system to make it more familiar for the users. Next, we have different instruction-driven interfaces. These interfaces, they are based on different types of languages, different types of syntax based on language. So the first of all is language-based syntax. It is built around a widely accepted command language that can be used to invoke actions. The idea is that the syntax is built on uh, commonly used uh, actions or verbs. For example, SQL is a very good example of these interfaces. In SQL, all of you know that we use select command to select the data from the database. Similarly, we use from, select asterisk from certain table where we provide a condition, Okay, we use order by to provide the order, whether ascending or descending, right? So you can see all these commands, they are taken from the natural language. Select, from, where, order by, drop, insert, delete. Okay, so all these commands, they are inspired from natural language. It is not completely natural language. The user has to memorize this syntax, has to memorize these commands, and only these commands can be used. But they are very easy to memorize for the users, uh, as you know from your experience of structured query language. Another is mnemonic syntax. It is built around command defined for custom information system. The commands are unique to that system and meaningful to the user. Well, some specialized system, they have specific commands which are or specific verbs or nouns which are used only in that domain. So mnemonic syntax, uh, it is like more strict as compared to this language-based syntax. Language-based syntax is understandable by any common individual. Mnemonic syntax is not understood by every individual, but for the individuals in a particular domain, in a particular area of expertise, or in a particular domain area, right? Like the doctors, they have specific language. Like in the travel industry, instead of using ABC, we use Alpha, Bravo, Charlie, Delta, and so on and so forth, right? So mnemonic syntax is like a natural language syntax, but it is for specialized domains and specialized system and users. The common people, they cannot understand it. The last one is natural language syntax. As the name implies, it uses the natural language to for the users to ask the questions or to do the things in the system. Like Apple Siri or Amazon Alexa, they are common examples of this syntax. You just talk to these systems and they will use natural language processing. We call it NLP, natural language processing, to process the natural language and do the actions or execute those commands, right? Here is an example for the structured query language. Question answer dialogue are a specific style for the graphical user interface, for the interface design. And as we discussed before that, they cannot be used as a standalone, as a single style for designing the system. Mostly they are used to supplement or support either a menu-driven interface or an instruction-driven interface design. So they are not used as a complete system interface, but they are used to support one of the other styles. So the idea is that the users are prompted with questions. The system asks questions from the users give answers, and then the system will ask more questions, the user will give more answers, and this way the users will be able to get something done. The strategy requires that you consider all possible correct answers and deal with the actions to be taken if an incorrect answer is provided. So they are very tricky. We need to consider all possible correct answers, and we should know what can go wrong. We should have a way of dealing with all incorrect answers as well. So that is why they are very difficult. They are not easy to design. Because of this reason, they are difficult to design, because you have to consider everything that can go wrong, everything that the user can do wrong in the system. So they are very rigid, they are very difficult to design, and they are not as flexible as, let's say, menu driven or the instruction driven interfaces. So that is why they are not used as a standalone style for designing the information system. You can compare, just to give you an analogy, you can compare these keyword dialogues to the telephonic helpline systems, right? Like that helplines, when you call at a particular number, you are provided with options. Let's say, first of all, you call the phone number of your bank. At the first step, they will ask you press 1 for Arabic language, press 2 for English language. Then you press a button on your phone, and then okay, press 1 for, let's say, customer services, press 2 for transaction, 3 for inquiry, and so on and so forth. So at every step, you are provided certain options. You select one of them, and then based on your choice, you are presented with more options, and so on and so forth. So just to establish an analogy, you can compare QA dialogues with these systems. So just like these systems, they cannot be designed as a complete interface. Similarly, QA dialogues, they can be provided as an additional interface style, but they cannot uh, act as a substitute to the menu-driven or instruction-driven interface designs. Right? Just to give you a very small example, this is a QA dialog for a car reservation system. Let's say you want to rent a car. So one way is, let's say you go to the website and you enter all the information to get a car rental, or uh, the system can ask certain questions from you, and you provide answers to all these questions, and then you will be able to rent a car. For example, where do you want to pick your rental vehicle is the first question. So in to answer this question, you will enter a location, or you will reply with a location. Where do you plan to return your rental vehicle? Again, you will provide a location. What is the pickup date and time? So you provide a valid date and a valid time. What is the return date and time? What type and size of vehicle do you need? Do you have any promotional coupons, and so on and so forth, right? So after answering all these questions, the system can provide you with some options, or system can rent a vehicle for you. Okay. Then there are some special considerations for the user interface design, like internal control, authentication, and authorization. We all know that for the service provider side, we need to authenticate, and for the user side, we need to authorize the user. So the system needs to provide a certificate to make sure that it is an authentic system, and the user, let's say, can provide a username and password to be authorized to use a system. So these are internal controls used to make sure that you are dealing with the right entity, and you are the right user with these access rights to enter the system. User ID and password, or privileges assigned to different roles, like you have studied in database course also, that we can define different roles to define different set of privileges. Like a student is one role, the privileges the privileges assigned to a student are completely different from another role, let's say instructor, or a dean, or a chairman of a department, right? And web certificates, they are used to authenticate the websites. Then online help. Nowadays, the users, they are more comfortable in using the web-based system. So mostly we also prefer to design the help as HTML pages to make it easy for the users. Then we can use any help authoring packages. We have discussed about them when we talked about IDE or SDEs, integrated development environments, or software development environments. We talked about them in chapter 13. Okay, so all IDEs or SDEs, they also have facilities to write the help in the system. Tooltips, whenever you hover your mouse to a particular icon or a command or menu, we can provide a very short description of that item. Let me check if I take you back. For example, here when I move my mouse pointer here, you see this tooltip, decrease list level, or when I move here, so it is showing bold, make your text bold. The shortcut is also given, Control B. So all these are tooltips, right? So you can consider providing tooltips to the users to make them clearly understand the purpose or the use of a particular item in your system. Then help wizards, if the task is very complex, we can divide this task into many steps as a wizard, or we can provide help wizards like for troubleshooting or for any problem in the system. It will provide a step-by-step guideline to the users to get help from the system. There are many different kind of wizards, like we have installation wizard. Okay, installation wizard, in which we divide the installation task into several steps. First of all, we give an introduction to the system. In the next step, you select the components to be installed. In the next, let's say you select the location where you want to install the system, and so on and so forth. The entire system is installed. Or uh, sometime for any complex task, we divide it into many smaller steps so that the user can easily complete the task uh, without getting overwhelmed by a lot of information or input fields. So similarly for help also, or troubleshooting, we can provide help wizards so that the users can learn to do something in a system. Just to show a few examples, here is an authentication login screen. The user gives ID and password, and if it is incorrect, the user is prompted with the screen. Here is a server security certificate to authenticate the server. We have help tooltips, like this is a tooltip, help agent, where you can provide the questions and the system can give you certain answers to these uh, questions. Another screen for help wizard. There are many automated tools that you can use for interface design and develop a prototype, like Microsoft Access. There are many case tools like Axure. Many students they use it for AXURE. Axure is one tool that can be used to design the interface or prototype. Microsoft Visual Studio, Excel, Visio. There are so many tools available that you can use to quickly develop a prototype of the user interface. There are many additional components or user interface controls that you can use in Visual Basics or in web-based system also. There are many scripts that you can download for many interesting components. Like here it is Outlook bar. Here these are different kind of progress bars, gauge controls. You can use this one or this one or this style. This is a slider control. This is a directory list box, font selection, for color selection. So there are many interesting controls that you can use to develop a very beautiful, very nice interface for the users. The last thing we discussed in this chapter is the process. So first of all, we chart the user interface dialog and we use the state transition diagram as we had discussed in the middle of this lecture. State transition diagram is a tool used to depict the sequence and variation of screens that can occur during a user session. So a as the name implies, state transition, how the state of the system changes, how the system changes from one to the other state, or whenever a user selects a particular item in a system, what he or she will see in the next step, and in the next, and so on and so forth. So it is a good tool, a diagram that can be used to organize all the inputs and outputs in your system. Just to show you a small example, here is a state transition diagram, a partial state transition diagram for a system. So first of all, we will have a security authorization. The user will enter the ID password. If the login is successful, now on this dialog, member services system, this is the main dialog. And in this dialog, the user will have 4 options. The first option is the, let's say, sounds ready option. So when this is the first option, the user select maintenance options, he will be taken to another dialog, which is soundstage options dialog. The second is this one, report and graph. So if the user selects reports and graph, he will be taken to report and graph. The third is this video titles. If the user selects video titles, he will be taken to this dialog. And the fourth is this one, the user selects membership, he will be taken to membership dialog. So on this dialog, we provide him 4 options. Okay, if the user selects first option, he will be taken to this. If the user selects second option, the third option, or the fourth option, right? So this is the first dialog, and for every next step, we also model the interaction. Like from here, what options user will have? User will have 2 options. One, the user select report type and create, it will be taken to this. Or the second is this one. If the user select, this one. If the user select graph type and create, user will be taken to this chart, right? Similarly, from here, the user will have this option, this one, not this one, this one. Similarly, from here, the user can have more options, right? So for every dialog, what is the next step, where the user goes, what options are provided at that step, and to the next, and to the next, and so on and so forth. So this way, at the end, when we have made a complete state transition diagram, we will have organized all inputs and outputs of the system in one diagram. And the user will have a clear path from the beginning to every possible input and output of your system. And definitely, you have to consider the workflow of the system to organize all these inputs and outputs in your system, right? So you should have a clear understanding of the workflows or the policies to be used in the system, right? So once we have organized all of them, now we need to develop the design. So we prototype the dialog and the user interface design, right? So if it is a web-based system, now we make a design of all web pages with the links, with the menu options, with icons, and so on and so forth. If it is a desktop system, we will develop a prototype with all the menus, the icon bars, the toolbars, okay, the pop-up menus, pull-down menus, dialogues, and so on and so forth, right? So we prototype the interface. Next, we get user feedback on this prototype. So if necessary, return to step 1 or 2. If there was a problem in the sequence, we may go back from here to step 1. We reorganize the inputs and outputs by making changes in the state transition diagram. Or if the order was correct, but some changes are required in the interface design, we go back to step 2 to make a new prototype, right? So we have covered today the basic guidelines for the user interface design. We have learned that input and output design, they are also a part of the user interface, but we need to provide some glue to link all inputs and outputs together, and this glue is provided by a user interface. Like for a web-based system, this is all the web page links, the menus, and so on and so forth. Or in a desktop system, it can be the menus and the icons and the dialogues that are used to provide a way to the user to invoke or to initiate all inputs, or to get the required outputs from the system. Okay, that's the end of today's lecture. Thank you very much. See you inshallah in the next week with the next chapter. Assalamu alaikum.